So this started like a few years ago. So I've been through a few of these processes in helping companies choose commercial off the shelf to solve a business problem. And I always found it a bit weird. Didn't seem to really solve the problem or pick the best option particularly from a technical perspective. And I'll elaborate why I think that's important. Hopefully in the CTO school meetup, nobody disagrees with that. So yeah, particularly in a digital sort of landscape, right? So have you guys seen this picture before? This is a pretty famous article. I actually have to pull up the reference for this, but I love the picture. So the bigger the thing is, the more money has been wasted in doing software implementations out there. And while I'm not saying that this is the cause of all of this, pretty much all of these tombstones, they have one thing in common. They all involve commercial off the shelf in some form or another to these things. And the bigger they are, the more commercial off the shelf stuff is involved in these projects. So if you think of this is $18 billion wasted in 2009. And you find a lot of these around. And you have some examples from Australia here. So this is 560 million Australian wasted in a piece of software. And then in July last year, this was on the news. So we have a government department that's going to be spending 7 years and $1 billion on an SAP implementation. They're actually replacing a system that has been in place since 1972. So the system should probably be actually replaced. Or, you know, the business process that it helps solve is probably still valuable. So they are, you know, changing the technology that enables that to happen. But who think that this is good money spent? Like, read their title. That's how they're basically selling this thing, right? Do you think that's money well spent? Who thinks it is? Shout.
Well, it depends on the outcome, right? If the outcome is that it works, then that's good. But
right.
Yeah.
Depends if they're paying IBM.
Sorry.
Or if you're an integrator. or if you're SAP. Yes. If you're SAP, it's fantastic, right? Okay, so I just thought this was relevant for this thing. So the first thing that the talk is about how to select commercial off the shelf, right? And I'm going to start by trying to change your mind in the first place. So don't buy it, just build it, right? And I'll try to talk you into this. Can you read this? Is this readable?
Yep.
More or less. Okay. So a colleague of mine, Eric Dornenberg, he's from ThoughtWorks, Germany. He's written extensively about how overall in the market, that's been a shift from, you know, just buying stuff to a lot more building, right? And you see very successful companies today. You know, you see insurance companies talking about how they are a software company that happen to sell insurance. And you see supermarket companies talking about how they are a technology company that happen to be in retail and that sort of stuff, right? So software is eating the world, right? As someone a lot smarter than I have said before. So make sure you consider this well before you go into the buy path. And the reason for that is, the first interesting reason about the whole build versus buy, and you know, like in which part of the company is okay to build, in which part is okay to buy. There's been a lot of talk about two-speed IT or bimodal IT, or how Martin Fowler likes to put it, bipolar IT. So this is very interesting, I find. So their basic argument is that you can't read system of differentiation. So is that you can have two speeds in your IT. Within your IT landscape, you can have two speeds of change, right? This is speed of change we're talking about. So in your systems of differentiation, where you talk to your customer, where you have your main business processes happening, you're really quick, right? You do the change quickly. You probably have deployment frequencies in you know, probably talking weekly, if not shorter than that. And then in your back office, in your systems of records, you have to be, I guess, a lot more diligent in your changes, and you have to put a lot more process around that. And your speed of change is a lot slower than it is in your system of differentiation. I think this is wrong. I think this is wrong fundamentally. And the reason I think it's wrong is because When you're changing a piece of, when you're changing your business model, you're adding a new product, or you're doing something fundamentally different to your business, that's basically what digital is all about, right? It's how do you use the devices and the new capabilities that the devices bring today to provide new services to customers, right? And if you think about that, I'm going to use insurance as an example, just because most people can relate to this. We've all bought insurance at some point in time, and I have a couple of actual practical examples of how this works. A lot of people talk about lemonade now. If you go to insurance companies, and I've spoken to a few insurance clients about this, they talk about lemonade. You guys heard about Lemonade? It's this startup in New York City that's taken the insurance world by storm. You can basically download, if you're in New York City, you can download their app and you can insure your house in like 30 seconds. You get a quote and they say yes, and you bought it, that's it. And it's a month to month, so you don't have to commit to a year sort of policy. You can change your mind at any time. You can add covers, remove covers. Everything takes seconds rather than, you know, an hour on the phone. And the price, they are effectively 40% to 50% cheaper than any of their competitors. So they're taking the insurance world by storm. And they're talking about going to the car business, the car insurance business, which is going to piss off a lot of people as well. So they talk about how can we be like Lemonade, right? We need to be like Lemonade. We need to create services and provide them in, you know, we need to get people to buy insurance from us, and the whole transaction needs to take like a minute. How do we do that? Can you do that just by changing your interface? Think about this, right? You've got your systems of differentiation. So can you create an app that sells insurance without connecting to your enterprise systems? How do you plug that back into your ledger? How do you do the pricing of that stuff, right? This all sits here. And that's why I think that this argument that you can have two-speed IT and dividing them this way is bogus, because you can't. When you're providing something new to your clients, the slice goes this way, not this way, right? The slice is this. It's in this direction. And they slice it at that. So I actually think you can have two-speed IT, but it looks more like this. You've got utility and you've got strategic, right? You slice it like that. You've got your utility systems here, or your utility processes, and they're not core to your business. There's a problem here, you gotta fix it, yeah. But it's not massive, right? This is not gonna piss off your customers. They're not gonna go away because something went wrong with this system here. On this, they will, right? But this, we're talking about both layers. You know, you've got the systems of records where everything gets kept down here, and your systems of differentiation. Does that make sense? So what I'm trying to say here is that it's okay to buy here, like go nuts, right? And this is my generic advice for building versus buying, which is you buy and you conform your processes to the way that the system works, and you go nuts on the utility side. On the strategic side, that's where you probably want to have your own stuff, right? So, and like I said, a lot of smarter people than I, people a lot smarter than I, have written extensively about this. So go and please read about this. And I'm going to go back to Eric now. So Eric said, so you've got basically the traditional reasons for buying software and the issues associated with those reasons, right? So the first reason people talk about we're going to build, we're going to buy instead of build, is that they say software development is risky, right? And in a way it is. Like any sort of product development capability, you might not get this right. But we've come a long way, right? If you think about the ERP era in the 80s and 90s, where people just bought SAP and Oracle and spent billions on that sort of stuff, that's where that comes from, right? Because software, we just didn't know how to do this properly. The industry was young, and we used to do these massive waterfall projects that, you know, when they failed, you're already $1 billion down the track, and like, oh shit, we got something wrong at the beginning. It's like, oh, okay, let's start again. And just a lot of money down the drain already, right? It's no longer the case. We have processes and tools to do this much better today than we did before. The other one is inefficiency. So this is, you know, scaling is hard, right? You start developing, you can have a nice small team doing something here, and you're like, oh, this is great. Can I have 20 of these teams? Like tomorrow, doing 20 of these things that they are doing, and keep up at the same pace, and not step on each other's toes and all of that. And that's just hard, right? Scaling in software is just hard. But again, we've come a long way. We know how to do this much better. There are architecture styles that can help you scale and that sort of stuff. You know, like microservices. You can have teams that split your business in meaningful domains that they can take care of that part of the business on their own, and then you can have a completely separate team independent on that side that they will do their own thing, and they get integrated at the end of the day using APIs. So we know how to do this much better today. So it's no longer a massive reason for buying. The other one is that software is not our core competency. So this is another reason people used to buy instead of build. It used to be fair enough, right? Most companies didn't used to be a software company, but even the narrative has sort of changed now. Companies say, you know, I'm a software company that happen to sell whatever it is that they sell. It's a common thing that you hear today. And the other thing is, we are in a digital age, and if you can survive for a long time without doing software, I mean, you probably have a pretty good business model. Keep going, go nuts, but not everybody's that lucky, right? Most people are going to have to get good at this, or partner with someone who is. Raising my hand here, if you need help. And then the issues, right? The issues with buying. So when you buy, you get given a whole bunch of stuff that you don't necessarily need. All of those features that you don't need, and by the way, you're paying for that, right? And it confuses people. They use the feature, it doesn't do what they thought you would do, and all that sort of stuff. And you got training and change management to make sure that people don't click the wrong button and end up selling to the wrong people and all that sort of stuff. Then you have COTS, they bring their own roadmap. And most of the time, you're not going to have that much influence in what happens next in the software, right? That feature that you really need to take your business forward, it's not the thing that the product that company is selling needs to do, because all the other customers, they don't really care about that stuff that you do, right? So the roadmap is to the product, not yours. And the main point, which I'm going to focus a lot in the rest of the talk, I feel like I've been talking for half an hour already, is that commercial, if you're implementing this in a complex enough business process or department in your organization, more often than not, you're going to need customization, right? Is that true? Most of the time? It is most of the time that I've seen, but maybe I've seen the odd stuff. And if you think about this, right, requires customization. How is this different than this? How are the problems that customization brings to the table in implementation different than it's risky, it's inefficient, and it's not your core competency? So you're going to tell me that Ruby or Java are not your core competency, but ABAP is? Right? Or whatever the language is, or that bespoke XML ugly that the COTS that you bought has as its way of customizing stuff, or, you know, putting fields in a database in a certain order.
Tiago, may I add one?
Yeah.
One of the things I noticed when I was doing a lot of consulting was that companies typically have this completely unfounded misconception that they're going to take their current process and apply software to it to make it more efficient or what have you. But the reality is, when you apply technology into an organization, it changes the process, changes the organization.
Yep.
And so you can't apply any kind of technology without changing culture and reporting and structure and everything about the process. And I think we don't talk about that enough.
So the change management aspect of it, I guess, right?
Yeah.
Yeah. So I agree. Yeah.
You can't do one without the other.
And if you think from the other perspective, if you just apply software, I'm going to say this in bad words. I'm being filmed, but sorry. So if you've got a shitty process and you put a software on top of it, you've got a shitty process automated, right? That's bad. It's going to produce shitty stuff more often than it was before. So you probably shouldn't do that in the first place. So you're right. You got to tweak it and make it better before you go about implementing a new piece of technology. So I use that as a plug. Recently at a client, again, like an insurance client, right? I'm going to give insurance example, sorry. They were looking at getting a new piece of software to manage, and it's the main example in this talk, to manage their product and policy business, right? So every time you buy a policy, that's where your record ends up in this system, right? Every time they say, we're going to sell this new thing, that's where the record for that new product that they're thinking about selling ends up living, so that you can buy it later. And as you can imagine, for an insurance company, that's pretty much their main system, right? It's where, you know, all this stuff that they are looking to sell and that they've already sold lives. It's their freaking main, it's their heart, right? It's the heart of an insurance company, is their policy and product system. And they realized that they had over 20,000 products, like several acquisitions along the years and stuff like that, and several types of products and several customizations that the clients could do to the products that made their product catalog look like 20,000 products, right? And that's just ridiculous. Like, how are you going to manage that, right? And you end up having products that, from a customer perspective, they provided the same benefits, but had different price points. Imagine if you really realized that. People made the math like, oh, wait a second, my friend has a policy with you or one of your companies, and these are the things he gets, and he pays $100. I've got exactly the same coverage, and I pay $500. How does that work? Give me my money back for the last, 5 years I've had this policy with you. So they're trying to, and I think they approached this in the right way, in the sense that they said, we got to figure out our product strategy first. We've got to architect how the products are going to look like, to then apply technology on top of it to get better, right? To be able to manage this a lot better than we do today. So yeah, completely agree. Right. So yeah, Eric is the guy that you want to check out, like I said. So this is what I said before. How is this any different than writing software in a generic language? All right. Let's switch gear a bit and talk about how companies do this thing, because ultimately I'm trying to propose a different approach here to how we can possibly do this. So the traditional approach starts with like this, right? Goa. Who knows what this is? You know what this is? You know what this is?
Beach in India.
Oh no, that's not the state in India. There is a state in India called Goa. No, colonized by the Portuguese. No, that's not it. So Goa is anything that ends with OA is oriented architecture, right? So this in IT, anything that ends with OA. These are golf clubs. So this is the golf-oriented architecture. So that's like what the executive wants to play golf with the executive from the vendor side, and they do a really nice shot. They're like, okay, I'll buy your product. And that's golf-oriented architecture. I hear that was very common in the 80s and 90s. I have not actually seen this happening live, but I hear it was a thing, right? It used to be a thing. I hope it's not anymore. I thought I would mention it, just so.
I think the US president.
Sorry?
I think the US president contributes to that.
Yes. Wow, shit, yeah, policy definitely still gets made that way. So there you go. So now, in all seriousness, this is usually what the generic approach looks like, right? You go and you think about planning and budgeting for a piece of software to solve a business problem. Then you do requirement gathering and analysis. Then you do a lot of vendor research. And this is where you probably go from, you have 10 vendors that have a product that fulfill roughly what your requirements are. And then obviously you don't want to be doing detailed analysis on 10 different vendors and products. So you're like, all right, we're going to rule these ones out based on X, Y, Z or whatever, right? So this is where you go from a slightly longer list to a short list of ideally no more than 2 or 3, right? Then you sit through endless demos and you get feedback from everyone participating in those demonstrations and stuff like that. And then you go about doing decision and contracting negotiations, right? And is this format look familiar to you? Like the format in this slide? Does this look familiar? Right, okay. This is waterfall, right? If you get anything wrong in any of the steps here, you're screwed. You got to go back to the beginning. You're like, oh, damn, all right. So let's go. We spent 6 weeks doing this. How about we start again? And nobody does that, right? Because it's a political Massive problem. Politically, you can't do that within a big organization. You're like, what? You just spent 6 weeks of this many people and you want to start again? No. You off. See you later. Find another job, right? That's probably the answer you're going to get. So nobody does it in the first place. So it's like, waterfall projects, they never really fail, right? They always go live and it's always successful. Yeah, we made it. It's like, yeah, nobody uses your thing, man. Nobody's using it. Yeah, but we're successful within budget, within scope, blah, blah. It's like, yeah, nobody's still using it. So that's what happens. And I've seen happening in a few of these things, right? And at the end of it, you get this, right? You all know Hippo, right? You know Hippo? The highest paid person opinion? So the boss of everything, like, you go through this endless process and then the boss says, nah, we're going to get that one there because, you know, my friend, he's a C-level in that other company, they said it's good. So we're going to go with that. There's a lot of decisions like that, right? So raise your hand. Who's seen anything like this before? Who's been involved in a process like that? Okay, keep your hands up. Keep your hands up. Now, keep it up if you think the process achieved the results that you wanted to. More or less? Okay, okay. Do tell.
That's how much you got. He said results you expected.
All right, I gotta change the words there. Hopefully expect something nice at the end. We gotta talk about expectations.
The first time, but not third, fourth.
All right. Okay. So I have done this exercise of getting people to raise their hands in a few audiences, and it's been a couple of people really keep their hands up. They're like, no, what? And they may as well have, right? But it's not because of. I think it's not. I don't have scientific evidence to back this, by the way, so feel free to call bullshit anytime. I don't think it's because of the process, but despite of, right? They got lucky. It's like, oh, this thing happened to have worked. Fantastic. But it's not because of the way we've done things, but despite of. Let's change gears again, and I'm going to get you back, hopefully, in the main thing. So what does good IT look like? What does good IT performance look like? Do we know this as an industry? We sort of do. I think we sort of do. So the State of DevOps report, which is the biggest sort of scientific study in this area, the 2016, which is the latest published version of it, has said this, right? So high-performance IT organizations, they deploy 200 times more frequently than others. They are 24 times faster recovering from failures. They've got 3 times lower change rate, or change failure rate. And the lead times is over 2,000 times shorter than their low-performance competitors, right? So this is what good IT looks like, right? In other words, or in another diagram, this is IT performance, and you break it down into 3 things, right? You've got deployment frequency, deployment lead time, which is basically cycle time, right? It's like someone from the business says, I've got an idea. Like, okay, cool, let's go and implement it. So it's from the time that the business says, I've got an idea, to when the software is live and delivering value. That's cycle time. Cycle time. That's what it is. The other one is mean time to recover. And that's the idea that you can't fail, right? Or that you invest a lot of money in the MTBF, so this is mean time between failures, right? So the idea here is that it's not that you don't care about failure and you don't spend money into preventing failure from happening. It's not about that at all. Actually, if you look at the report says that the high-performance organizations, they do both correct, which was an assumption in older process IT, that you can either be quick or you can be resilient. You can be secure, right? So you have to choose between one or the other. And it happens to be, they walk together. They actually, the chart goes hand to hand. They walk in the same sort of rate. So if you deploy fast, you also fail less, right? But deploying faster, you recover a lot faster than anyone that deploys less than you. They fail more than you, and it takes longer for them to recover. So you got to think about the mean time to recover, right? And again, this is the ability to deploy fast. I'm going to make this super simple now. What happened? All right, in a few words. So the ability to respond and change quickly in safety is what makes good high-performance IT organizations. So this is the trick, right? You got to be able to move quickly, change quickly, and safely. Put shit in production. That's what good IT looks like. How can I put stuff in production as quickly and as safely as possible? That's what good IT looks like. Are we in agreement with that?
Missing value.
Right. Sorry?
You're missing value. You can put shit into the market as quickly and safely as possible.
I think they go together. It's probably a different talk. We can talk about how software is an experiment in its nature. All right, we need to catch up later. I think it goes together. You never know if the thing that you're doing has value until you kick it out there and customers go, all right, this is useful or not. Right?
I'm sorry, I added another profanity to the recording.
It's all good.
I think we already
I'm
had
probably
some.
going to do this a lot in our JavaScript.
Microsoft made a lot of money.
Sorry?
Microsoft made a lot of money by throwing shit out in the market.
Yeah, and look, and the IT, I guess the IT industry has progressed a lot, right? The waterfall way of doing things was the way that it was how we knew how to do it. But also, it worked for a long time, right? It's a process that actually worked for quite a good period of time. It made people a lot of money, put it that way, right? But, you know, some people have found, they've found better ways of doing this, and they started making more money than the others, and that's, I guess, how we're changing as an industry. And then you look at it, Microsoft now, they're a very different organization than they were, 15 years ago. So you got Office 365 today. They release new versions pretty much every week, if not more often than that. So it's a completely different organization today. So what can we do differently, and what can we reuse from all of this, right? So what sort of practices can we need to do it differently, and what do we need to reuse? Right. So yeah, I'll talk about this. So I wish someone had written a book about how to deliver software quickly and safely, right? That would have made our jobs a lot easier, right? Oh wait, someone already did. There's a book about that. There is literally a book about how you can deliver stuff safely and quickly to production. It's called this. It's continuous delivery. A set of engineering practices that you apply to how you deliver software. You'll make it quickly to production and safely, right? And it has 3 simple pillars to this. One is configuration management. In other words, put everything in source control, right? Everything that makes up your product at the end goes into source control. And version relentlessly. Automated testing. And I would actually strike the testing word here and just pretty much automate everything that you can, infrastructure. Nowadays, a lot more is possible than when this book was written. So automate more than just testing, but definitely automate testing. And the other one is continuous integration. And continuous integration is the ability to, or the engineering practice to slice things in very thin slices and commit into source control, which will trigger the tests and make sure that you're always green in terms of quality and that you're ready to go to production at any point in time. Right? So basically you create a pipeline that gives you the ability to go to production anytime that you want. Does that make sense? Everyone with me still? Okay. So I basically brought you back to the topic now. So customizations need to be version controlled. So applying these topics now to commercial off the shelf. So when you're picking something, and this is where I said that I think that the engineering practices didn't really align to, I guess, what the IT industry expects in terms of speed today. So customizations need to be version controlled. That means that everything that you change if you're changing the behavior of the software through customizing it in whatever way the software allows you to customize it with, then you need to put that customization in version control. Right? That's how you would be able to then achieve continuous delivery. Right? And this becomes tricky, right? So some software, they allow you to completely change their behaviors by setting a flag in the database somewhere. Right? Imagine, how are you going to move, if you know where the flag lives, even if you know where the flag lives in the database, how are you going to move that between environments? How are you going to test that when you set that flag, the software does what you expected it to, right? From a business process perspective. How are you going to maintain I guess this problem here is how you're going to maintain that configuration in a source control repository, so when it changes, you know, and you can go back to. So sometimes it's database driven. Sometimes software have their own programming language, right? ABAP. So this one software that we evaluated in this insurance company had its own JVM basic language, right? Which, if you ask me, is great because it runs on the JVM. So whatever you can do in the JVM, you can do in the thing, right? So it's actually pretty good. And the language was actually nice. They had Lambda before Java did. So kudos to those guys. And sometimes it's XML or even the UI. And then you got to figure out, like, what the heck does this button in the UI do? But I don't know what it does in the back end, but it completely changes the behavior of the software. And if someone pushes this button in the wrong environment, we're completely screwed as a business, right? And even tracing that back is going to be impossible, right? Think about mean time to recover here now. All right, automated testing. So have you seen this? This is the testing pyramid. Testing pyramid is a thing that we use to illustrate where you need to spend your time writing tests on. Right? The idea is that you write most of your tests in the base of the pyramid here, which you call unit tests. And the reason you do that is because, well, first, hopefully you're doing TDD. So that thing happens automatically if you're doing that. And the other bit is, unit test is cheap. It's very cheap to write a unit test and to run it, right? You write a unit test here as quickly as you write a function in any programming language. And it runs in milliseconds, right? So you can have thousands of these things here, and your pipeline is still going to be fast as, right? It's just going to run super quick. Then you've got service integration tests in this level here, which are more elaborate tests. So you don't want to have as many of those as you have of unit tests, but they're important as well, right? You want to see how things work when they hook together and that sort of stuff. So you want to have those tests as well, but a lot more here, less here. And the UI-driven ones, you know, we're talking about the Selenium or whatever automation framework you happen to choose, and you got even less of those, right? You're probably talking about a handful of your main user scenarios, like what your users care the most about. You're probably doing UI-driven tests about those things, right? And this is interesting because if the software provides you a way of customizing it, does it provide a good way for you to test it? Test the customizations. Can you switch that flag and write a test that makes sure that the software is going to behave the way you want it to based on the flag that you just switched? Right, so those are the things that you gotta be asking about, and particularly, can I write the test in this level rather than all of those in this level? And going back to the example in the insurance company, at the end we had two vendors competing for this, and this is it's a big deal, right, in terms of money. So these guys, they were fighting like crazy. These are two really big vendors, and they all really wanted the business badly. And one of them had a really good answer to testing. They had their own framework. You could do mocking, so you could mock out the database, so you don't have to hook up to the database to do testing. You could do all sorts of nice stuff on their framework. And the other one said, yeah, Selenium, like for everything. Like all of my tests, they have to be Selenium based. This is going to take, you're going to run a pipeline for 10 hours if every customization I make to your software will run a Selenium test for it, right? And on the top of it, I don't know if anyone's written Selenium or run Selenium tests before. They fail out of the freaking nowhere, right? And they run again, and it worked. Like, what the fuck happened? So they rely on the browser and that sort of stuff, and they're just brittle. And that's why we write 5 or 10 of them and not 50,000 in this, like we're doing unit tests here. Because it's expensive to write, it's expensive to run, and they're brittle. They're not as effective as the other ones. Okay, automation. Automation's a good one. So if you have the two above, unit testing and put stuff in source control, the other techniques that you need to achieve continuous integration, which is what I mentioned before, they're less technical, right? The technical bit is about how you put stuff into source control and how you test. Then it ties a little bit into this, which is how do you move that, right? Imagine that if your customization is database, you have to think about how am I going to move that particular customization that I made into the next environment. Are you doing a DB migration? Or how can I run the XML from this environment to that environment, apply it to the next environment and that sort of stuff? Or can I create the environment from scratch? Does this run on the sort of infrastructure and operating system that allows me to just go and create the environment out of, in a cloud sort of provider out of nothing? Which is probably what you want, right? Make sense? And this is, I got a caveat on this point, which is, you got to think about how this requirement applies to software as a service kind of offerings, right? So if you're talking about buying a CRM, for example, which is probably the simplest example to give in this context, and you're looking at, I don't know, let's say Dynamics from Microsoft, and you look at Salesforce, they both have SaaS offerings, and one of them is just SaaS. And so automation is an interesting aspect because they do have the concept of environments, right? Can you spin up environments as you will? Can you apply all the configurations that you have in one environment in the next? And that sort of stuff. So you really got to think carefully about this. Which ties nicely to the last, like other really important stuff that I think doesn't get enough attention that we need to think about, which is so one of them is permissive licensing, right? Ties back to the last point. Like you want devs or customizers, whatever they are that you call them, to be able to spin up their own environments and do their testing and make sure that, you know, that flag that they're switching ends up doing what they want it to do from a business perspective. So you want to have permissive licensing, particularly in non-production environments, which vendors are really, really bad at this. They're like proper bad at this. They will charge you another $1 billion just to get a box like in the corner running the thing, right? So you gotta really look out for these things. So integration endpoints. I mean, we're talking about enterprise environments here. So integration is a given. You're gonna be integrating this thing with a million other things. So how well does it do that? Can you break the software down into smaller chunks and implement those smaller chunks and realize the value and then go into the next thing and then go into the next thing? So this is modularization. Obviously, there's one here that I haven't touched, and this is on purpose a little bit, which is, you know, hopefully it solves at least one business problem that you have. Otherwise, we wouldn't be having this conversation in the first place, right? So the thing's got to be at least slightly useful from your business perspective. The other one is upgrades. So a really common thing that happens when you buy one of these big piece of software is that a year down the track, which is you're probably still in the middle of your implementation, they release a new version and like, oh, great, can I have that? So nah, all your customizations, they're not compatible. So you got to pay again to implement the customizations in the new version. They're like, oh, really? Okay. How does that work? That's a massive money-making machine, right? So you got to really be careful about that. And this is, I'll be honest, this is the one that I have the least good answer for. Is that how can you mitigate? These are all risks, right? The other way of looking into this is like, are you trying to minimize risk? How can you minimize the risk of getting shot with upgrade prices? Just a couple of years down the track, and yeah, this is a tricky one because you gotta rely a lot on what your vendor will tell you that the next version is going to be like and how it's going to handle all of the other stuff that I just mentioned, right? So that you can reasonably know whether it's what your chances of those things working or not. Or you can customize stuff on top of the software using proper programming languages and environments and stuff like that. But then it's a different conversation. So right, have I bored you yet? This is a really boring talk, I know. It's a boring topic on its own. I don't know how people come to these things or why. Right, so this is a sort of a test talk. This bit, I'm not 100% sure yet, so please, I really need feedback on this thing. I'll be ready for a Java straight, don't worry. So the one thing that I find really good in the science behind selecting software, there's a lot of science behind this, by the way, not the other stuff, but selecting software is an MCDM problem. It's a multi-criteria decision management problem, which is a field of study in science, in political science. Kid you not. And AHP and TOPSs are sort of flavors of MCDM. So I don't know. So if you go back to, don't know if you've seen this before, you probably have, but you just didn't know it was MCDM. If you go back to how, in the demonstrations, if you think about it, if you participate in one of these, in the demonstrations, if you were part of the decision making, someone probably handed you like a sheet of paper that you had to, rate the software in certain criteria, and you had to say it's, between 1 and 9 or 1 and 10, whatever. It's 3 on this, it's 9 on that, it's 4 on that. It's like, this is MCDM. That's MCDM. And it's probably AHP. It's the most common one used in software selection. And that's really good science. This is really good science. There's a lot of backing behind this. So this is one of the things that if you're doing one of these, I would probably use parts of MCDM and AHP. So have a read of this. If you're really interested in this, I can point you in the right direction, the right studies that talk about this, these two topics. But the idea is, MCDM is, you got conflicting criteria, right? And it's usually some sort of cost versus some sort of quality, right? And the simplest example is, you buy a car, right? You've got a whole bunch of quality criteria. You want it to be this safe, you want it to be this comfort level, these many, whatever, right? That you look for when you're buying a car, and you're like, and this is sort of my budget, like roughly, and those criteria are often conflicting, right? You're like, all right, this is my budget, these are the criteria, and you wrote down the criteria for a Ferrari. It's like, man, that's probably not going to happen based on the, on the budget, but what is the next best thing that you can get, right? So that's basically the idea of MCDM and the problem it solves. The other bit of the problem that it solves is that when you're doing software selection in enterprise organizations, what you have is not only conflicting criteria, but you also have conflicting priorities between people participating in the process of doing this, right? So it helps solve that problem as well. So how do you balance the different priorities between people doing these things? The AHP is just an analytical hierarchy process. The idea that you have a big problem, so your big problem is select software, right? You're going to do this. Your big problem is selecting an ERP. And you're like, oh damn, that's too big of a problem. How can we break this down? Like, all right, let's talk about the vendor, let's talk about the product, right? And then you're like, okay, there are 2 big problems now, but smaller than the ones, the hierarchy above. All right, let's break this down further. Like, how do we talk about the vendors? Like, oh, are these guys do they have a good reputation? You probably want to buy from someone that has a good reputation. Do they provide good technical capability? How is their service, right? And then you further break that down into other criteria. A lot easier to answer these questions than these, right? And then you go into the more specific stuff, right? That's basically what AHP does for you. And there's actually a mathematical way of coming up with turning those things into numbers. Basically what you do, and I'm not going to try to explain this to you right now because it's even more boring than what I'm saying right now. But basically what you do is you rate each category against each other. And then you have a relative measure of importance between the criteria that you have.
Yeah, that's the hard bit though, isn't it? Working out your relative measure of importance for the criteria, particularly when you've got different people in the business wanting different things.
On its own, it's an MCDM problem, right?
Yeah.
Yes.
Turtles all the way down.
Yeah. It's a meta MCDM problem. Right, so what can you do? I told you all about, how crappy it is to think the stuff the way that we've been doing this so far. Actually, I tried to talk you out of building or buying in the first place in favor of building. It's like, oh no, I still want to buy. There's a really good software out there. It's like, okay, cool, fair enough. So what do you do what's my proposal, right? So what do you do better than what the current waterfall approach is, right? And the demo heavy and that sort of stuff. And my answer to that is, you gotta get your hands dirty, right? You gotta experiment. You gotta get your hands on the actual thing that you're trying to buy. If you just go about watching demos and you rate the software based on what you've seen on a PowerPoint presentation or someone else driving the computer and not your folk doing it, then you're probably gonna make a wrong decision, right? So obviously, try to not do this, right? These are bad, these are really bad, so don't do EBOs, don't do Goa. Try to do Agile, which means deliver value quickly, right? It's no more than that. And try to make small decisions instead of really, really big ones. And this is sort of how it looks like. So you still got to choose between A and B, right? You still got software A and software B in the mix, and you're like, all right. And you've thought about all of the biggest risks that you have to your business. So as these look like, we've got these many products today. We got to put them into the system until we re-architect the product strategy. And then you've got like, all right, so we want to respond to change quickly. And this is the main thing, right? You've got to be able to respond to change quickly. So what are the hypotheses that you have? And then you feed that into 2 teams, or hopefully you've got no more than 2 or 3 at the end, right? So if you've got 3, you're talking about 3 teams here. And this is important as well. So you have both developers, users, and the business outcome owners here, and architects. They are involved in the process, right? So what I'm saying here is, instead of just watching demos and that sort of stuff, get this piece of software in front of the people that are actually going to use this day to day. Get the software solving an actual business problem that you have, and put that in production. Actually exercise how that thing would work in your environment all the way through to realizing value. And you do that for A and B. And once you're done with A and B, you're gonna know a lot more. And this can take 2 weeks, 4 weeks, right? Maybe 8 weeks, but not months on end, right? And by the time you get to this end here, you have learned a lot more, and you know what the compromises would be for software A or software B, and you can make an informed decision. You can actually make an informed decision at this point, and hopefully you haven't made any commercial agreements by then. The decision might actually be, oh shit, but the speed that we want to have in our business, neither of these platforms would allow us to do that. Or you can say A actually does this really well. So if I go back to the example of my client, they have picked one. And again, you got to be careful not to fall in the fallacy that you started something, so you got to pick it just because you might look bad at the end. If you don't, it might look like money wasted. And to do that, you have to have a culture that allows for, that permits failure in that sense. But they did. They selected one, and they're still probably implementing it. And if you ask me, their choice between A and B was the right choice. I think they selected a software that allowed them to move a lot quicker than they would be able to with software B. And the main reason, and the reasons for that was, like what I mentioned, like A had a lot more testing capabilities, and the customization was done in a way that you could actually write in a language that people in that organization were most familiar with, so JVM. It ran on the JVM. Right. Yeah, does that make any sense? So if you didn't get anything out of this, the main messages I'm trying to pass here are basically that, are you sure you want to buy? That was one of the main ones. And the other one is like, have you considered the actual risks and how you're going to be mitigating them? And I think the biggest risk for digital organizations today is to be slow. So that is the main risk that you have to try and mitigate when you buy a piece of software. That's it. That's all I had.